Hi, so today we're just going to do a reminder of SOHCAHTOA to start with, and you'll see why we're doing this in a minute. So what we're going to start with is just by finding the angle in this right angle triangle. So this is going to be, that's the opposite side of the angle there. This is the hypotenuse. It's going to be using sine. So sine theta is equal to the opposite over the hypotenuse. So sine theta equals 3/7. And then what you can do now on your calculator, as you should know, is you can do this sine -1, and that will get you your angle. So what is this sine -1? I mean, what you're basically doing is you're applying the, I guess, inverse of sine to both sides of your equation there. And then what that does is that gets rid of the sin on the left hand side, so you just get a theta there, and then you apply this sin inverse to the right hand side. So we use kind of like this sin, cos, and tan -1 operations to kind of solve the angle to find out what this angle is. So we can think about sin -1, cos -1, tan -1, tan -1 as inverse functions to sin, cos, and tan respectively. However, there is an important point that we need to make about calling them inverse functions, because they're not actually inverse functions, this sin -1, this cos -1, this tan -1. So let's draw. So we've drawn out the graphs there of sin, cos, tan. So what do we notice? Well, sin, cos, and tan are all many-to-one functions when their domains are all of the numbers on the x-axis. So, for example, I mean, you can do what we did before, the horizontal line test. Draw a flat horizontal line. We've got 2 points of intersection. So this is called a many-to-one function, because many x values on the x-axis map to one point on the y-axis. And again, a similar story here, a similar story here. These are all many-to-one functions, and we know that many-to-one functions don't have inverse functions. So the key point down here is they do not have inverse functions. So even though we can use on the calculator sin -1, cos -1, and tan -1 to work out angles of any size between -infinity and infinity, if we are going to consider sin, cos, and tan functions between -infinity and infinity, or the real numbers, they do not have inverse functions. So that's something we need to bear in mind. However, we can restrict their domains so that they become one-to-one functions. So remember, we can change the domain of a function so that we can change the actual function, because functions can only be defined with a domain. So now we can actually restrict the domain of the sin, cos, and tan functions so that we can actually get a one-to-one function. And the key point to remember is that one-to-one functions, all have inverse functions. They all have inverse functions. So now we can actually, if we change the domain of these sin, cos, and tan graphs to obtain one-to-one functions, then we can get an inverse. So what we can do here is actually, if we restrict the domain here between -π/2 on the sine graph and π/2, what you'll notice if we just chop off here and here is that inside here, in this gap, in this like region here, we've got a one-to-one function. So again, if you do like this horizontal line test, there's only one point of intersection. This is a one-to-one mapping in this region here, in this like domain of x values. So actually this graph, again, between -π/2 and π/2 of sine, this is now a one-to-one function. So this here is actually now a one-to-one function. So going between -1 and 1 on the y-axis, this is now a one-to-one function. So when x is trapped between -π/2 and π/2, yeah, this is actually a one-to-one function. So we now get a one-to-one function there. And we want to do a similar process with the cos graph. So again, if we think about a cos graph, let's try and restrict the domain so we get a one-to-one function. Now, what I notice, I mean, obviously, if we draw a flat horizontal line across, we're going to get points of intersection. But if we cut off the graph at x equals 0, and if we cut the graph off here at pi, x equals pi, then now in between here, we get a one-to-one function, because now every y value has a unique x value that maps onto that y value. So we've got a one-to-one function between x equals 0 and x equals pi. So actually, if we draw the cos graph specifically between x equals 0 and x equals pi, like this, down to -1, this is now a one-to-one function. So our domain, if we change the domain, restrict it to 0, x is bigger than or equal to 0 and less than or equal to pi, we now get a one-to-one function. And let's do something similar with the tan graph. So this one's actually quite a little bit more obvious, because actually we can see from the asymptotes, we've got an asymptote there at -pi/2, we've got one there at pi/2. I mean, we could change again similar with the cos and the sin graphs. We could actually go to different parts of the domain and restrict it in different parts. However, we don't need to really. Well, I mean, we don't need to, because that's not how these how we defined what we'll see in a minute, but we'll get there in a minute. So yeah, again, we could restrict the domain between -pi/2 and pi/2 on the tan graph, and in such case we will get this one-to-one function, this one-to-one curve here, which looks something like this. And now again, we've got a one-to-one function. So our domain now is -pi/2, less than or equal to, well, less than actually, because we can't equal -pi/2 because that's an asymptote, and then less than pi/2. So this function here now does have a it does have an inverse. Sorry, let me just make my writing clearer, that this is a pi here over 2, and that's not a 12. This is a negative pi/2, negative pi/2. Okay, there we go. Right. So then, okay, so now then we've restricted the domain, we've changed the domain of these sin, cos, and tan functions to get one-to-one functions. Again, like I was trying to say a minute ago, you can restrict the domain in different places along the number line. I mean, you could do it in different other places, but we're going to do it in these specific places. And the reason why is because, again, well, we know that if we restrict the domain in those specific places, we will obtain one-to-one functions. So yeah, all these functions here now have inverse functions. They all have inverse functions. So inverse functions. And in fact, they all have a name. So these specific, so again, the reason why we've restricted with these specific parts of the domain is because these specific inverse functions, the inverse functions to these specific functions, all have a name. So the inverse function here is called ARCSIN. So the inverse function to this function here is called ARCSIN of x. The inverse function to this one here, the inverse function to this specific cos function, is called ARCCOS. So ARCCOS of x. And the inverse function to this specific function is called ARCTAN. Sorry, it's called ARCTAN of x. So ARCSIN, ARCCOS, or ARCTAN, these three functions are the inverse functions of sin, cos, and tan, specifically when sin is between -pi/2 and pi/2, when cos is between 0 and pi, and when tan is between -pi/2 and pi/2. The inverse functions are called ARCSIN, ARCCOS, ARCTAN. And tomorrow we will look at how we actually sketch those graphs and what the graphs of ARCSIN, ARCCOS, and ARCTAN all look like.